Welcome students, welcome to classroom. In today's class we'll be learning about a very important topic which is called oxidation and reduction. So this is very important, okay, and it's not very difficult also. So I assure you that you will learn, okay. So let's start the class. So oxidation and reduction. What is oxidation and what is reduction? Now see, oxidation is gain of oxygen and reduction is gain of hydrogen. Okay, so let us discuss in detail what oxidation and what reduction actually is. So this discussion we will do with respect to lose and gain. Okay, lose and gain. So let us have a look. Now see, oxidation and let's say reduction. So what is oxidation? So in terms of gain, in oxidation, what happens is that they gain oxygen. So they gain oxygen. So reaction where they gain oxygen, a chemical reaction where oxygen is gained will be known as oxidation reaction. In terms of gain, how do we discuss reduction? In terms of gaining, in reduction reaction, they gain hydrogen. So gaining of hydrogen will be known as reduction, and gaining of oxygen will be known as what? Oxidation, is it not? So reactions where oxygen is gained or where they react with oxygen is known as oxidation. Reactions where they gain hydrogen, okay, or they react with hydrogen will be known as reduction. This is in terms of gain, okay. But see, understand it like that. In order to gain, you have to lose something, okay. So it works both ways. So in one of the story is about you gaining. Now there's another story where you lose. So in terms of losing, okay, there's a story for oxidation. So similarly, in terms of losing also, there's a story for reduction. So remember this. See, you are gaining oxygen, okay, so you cannot lose oxygen. Now if you lose oxygen, then why did you gain oxygen in the first place? Isn't it? Why did you even take it if you don't need it? So you cannot lose oxygen because you gained, isn't it? You said I want it, so you took it. So now you cannot discard it. You said you said you will take it. You know that it's important for you, so you took it, so you keep it with you. Okay, so you cannot lose oxygen. So since you are gaining oxygen, since you took oxygen, you cannot lose oxygen here. So what will you lose? You will be losing hydrogen. Okay, so in oxidation, we gain oxygen and we lose hydrogen. Now the same discussion will be done for reduction. In reduction, you are gaining hydrogen. You know that it's important, so you took it. Now you cannot lose it, so you'll have to keep it with you. Then what are you losing? You have to lose oxygen. So any chemical reaction where oxygen is lost, is known as reduction reaction. Are we clear? Okay, so it's very simple. Okay, oxidation is gain of oxygen. Reactions where oxygen is gained is known as oxidation, and reactions where hydrogen is lost. In terms of loss, hydrogen is lost. Reactions where hydrogen is gained is known as reduction. Reactions where oxygen is lost, okay, is known as reduction. Very easy, isn't it? Clear, na? It will be more clear, okay, and it gets more interesting when we do chemical reactions. So let us do some chemical reactions here. Now I'll be discussing the examples from the textbook. So we have the first example: copper plus oxygen. So copper plus oxygen means copper reacts with oxygen. Copper reacts with oxygen. Okay, what will happen here? You'll get Cu. You'll get CuO. Okay, you'll get CuO. So copper reacts with oxygen. Okay, what you get? You get CuO. See, copper has gained oxygen, isn't it? Copper has gained oxygen. Copper has gained oxygen, okay? Oxygen has been gained, okay? So this is an example of oxidation or reduction. This is an example of oxidation. This is an example of oxidation, okay? Where oxygen has been gained. Who has gained oxygen? Copper. Copper was an element here, isn't it? Copper was an element here. It reacted with oxygen. What happened to copper? Copper became a compound. Copper got oxygen, and now this is copper oxide, okay? So this is oxidation. All right, now let us take another example from the textbook, which is yes, copper oxide, the same compound here, plus hydrogen. Now what are the product? The product is copper plus H2O. Now this is going to be interesting. Now time, okay? Now we will do this in a different technique. Now see, we will be drawing lines to show the connection, okay, to show the connection. So okay, you see copper here? Yes. You see copper here? Yes. So copper, I see copper here, I see copper there. What do? I draw a line connecting, okay? And I start from the left hand side, so no arrow in the left hand side and arrow on the right hand side, or you can put arrow both sides also. So I see copper here, I see copper there, I draw a line. Got it? Then I see hydrogen here, I see hydrogen there. Again, there's a connection here, there's a line here, so I draw a line. Okay, I draw a line. Now time to tell you what this line is about. Okay, why did I even draw a line? Okay, so I drew a line because there is a story happening here. What is the story here? See, copper oxide. Now look here, it is copper oxide, and look me here, I have lost oxygen. Here copper is with oxygen, this is copper oxide. And now look at copper here. Do we see oxygen here? No. So it has lost oxygen. It has lost oxygen. It has lost oxygen. It's not. It has lost oxygen. So losing oxygen. What reaction? Reduction. So here reduction has taken place. Alright, students? So reduction has taken place. Alright, so simple, isn't it? Now you look here. Okay, now hydrogen and this hydrogen. I have drawn a line, isn't it? Now time to describe the relationship here. Now what is the relationship here? This is hydrogen gas. Okay, I see hydrogen gas, I see hydrogen gas, so I have drawn a line. Now time to tell you what this relationship is. Now I see hydrogen gas, but I see water here. So this hydrogen has gained oxygen. This hydrogen has gained oxygen. See, previously there was no oxygen here. This was just single hydrogen atom. Now you see oxygen. This hydrogen is bonding with oxygen. So I see oxygen. That means it has received oxygen. It has gained oxygen. Gain oxygen. Gain oxygen. Which reaction? Oxidation. So this is not a question mark, but this is, now we have identified this to be oxidation reaction. So simple, isn't it? So simple. Okay, so reduction, oxidation. Reduction because it has lost oxygen. Okay, oxidation because it has gained oxygen. All right, easy, na? We will do some more. Okay, so we'll do one more again. So zinc oxide now. Zinc oxide plus copper gives zinc plus CO. Zinc plus CO. Now, I am sure you can do this. You can pause the video and you can try this. So the first thing here that the student struggles is how to draw the line. Okay, so I'll teach you how to draw the line. See, to draw the line, what happened is always look. Okay, look at this. Okay, look at this. See, previously here I told you to look at copper. Isn't it? I see copper there. I drew a line. Now look at this. Here I have zinc oxide. You can pay attention here, zinc oxide. Okay, now zinc oxide, I see zinc oxide, I see zinc. Okay, so try to connect this. Okay, try to connect this. So I see zinc oxide, I see zinc here, I see zinc here. Okay, I see zinc here, I see zinc here. Okay, don't look at this oxygen for now. Okay, I see zinc, I see zinc. So draw a line here. Okay, draw a line here. All right, now next. Okay, only one line from one element or one compound. Okay, now we go to the next one. Okay, there are two reactants here. Now we go to the second reactant. I go to this carbon. I see carbon here. Now I have to search for carbon there. I see carbon here. I see carbon here. So again, I'll draw a line here. Okay, that's it. That's how you draw a line. Okay, so now let us try to write what it is. Okay, what type of reaction is this? What type of reaction is this? So this is zinc oxide. Zinc oxide, and this is zinc. Lost oxygen. Oxygen is not there. Oxygen is lost. So zinc oxide becomes zinc. So losing oxygen, isn't it? Zinc oxide has lost oxygen and has become zinc. So this is reduction. Okay, I'll just write R. Then this is carbon. Carbon becomes, this is carbon monoxide or CO. So let's say just say CO. So carbon has become CO. Single C. Now oxygen is with C. So it has gain oxygen. Okay, what is gaining oxygen? That type of reaction is known as oxidation. So this is oxidation. So this is oxidation. So this is oxidation. And this is reduction. Simple, na? Simple. Okay, now we will do one more again. So manganese, MnO2. I think it's MnO2. Yes, MnO2 plus HCl. Okay, then MnCl2 plus H2O plus Cl2. H2O plus Cl2. Okay, I want you to pause the video and then draw the arrow. Done. So now let us first draw the line together. Okay, because drawing the line is also a challenge, isn't it? So okay, so I will start with the first element here. I see manganese. So what will I do? I'll go and search manganese from the product side, isn't it? From the reactant side, I have manganese. I'll go and search manganese from there. Okay, so I'll search manganese from there. So I see manganese here. I see manganese here. I draw a line. So यहाँ से from here till here. Okay, there is something going on here. Okay, we will discuss what it is. Okay, then next one. I see chlorine here. Okay, I see chlorine here and I see chlorine here. Okay, so I draw a line. So chlorine here and chlorine here. I draw a line. Okay, got it? So I see chlorine here, I see chlorine here, I draw a line. Now this is manganese oxide. This is manganese oxide and this is now manganese chloride. See, manganese oxide, manganese with oxygen. Okay, it has got oxygen with it. Here I don't see the oxygen. So manganese oxide becomes manganese chloride. So it has lost oxygen. No more oxygen with manganese. It has lost oxygen. So this is which reaction? Reduction. So this has been identified as reduction. Okay, this has been identified as reduction. Okay, now look at this. This is HCl. Okay, chlorine and hydrogen together. Now I go and check this chlorine. Now no more hydrogen. No more hydrogen with chlorine. Only chlorine. So hydrogen lost. Loss of hydrogen. What reaction is that? Oxidation. So this is identified as oxidation. All right. So this is how it is done. Okay, it's not difficult. So these examples, you practice them again and again, and I'm sure you will be able to master it. Okay, so the concept of oxidation and reduction is not very difficult. It is discussed in terms of gain of oxygen and gain of hydrogen, loss of hydrogen or loss of oxygen. So if it is oxidation, then gaining of oxygen is known as oxidation. Okay, whereas gaining of hydrogen is known as reduction. Reactions where we lose hydrogen are known as oxidation reaction, and reactions where we lose oxygen are known as reduction reaction. Okay, so oxidation and reduction are two important chemical reactions that you have to study in this lesson. Now, small topic is left again about rancidity. So let me just cover up that here. Now. That will make this That'll make it the last topic for this lesson, rancidity. Okay, so let me talk about rancidity. So rancidity. What is rancidity? See, we have already discussed about oxidation. Okay, oxidation is reaction with oxygen. Now, food items, okay, especially foods which contain fats and oils, okay, when we keep them exposed to the atmosphere, since air has oxygen present in it, they react with the atmospheric oxygen and they undergo oxidation reaction. Okay, so this is known as rancidity. Okay, in terms of food, okay, we have a fancy name for it. We call it as rancidity. So rancidity is just simply oxidation of food items only. Okay, so you just have to remember the name. The definition of rancidity is what? Very simple. Oxidation of food items. So rancidity means oxidation of food. Oxidation of food. Okay. Oxidation of food. In simple, oxidation of food only. Okay. But the actual definition, okay, the definition which you should write to score good mark is different. So the definition of rancidity, I'll give you the definition of rancidity. Food items. Okay. Oil, fat and oily foods. Okay. Oily foods or foods which contain fats. Okay. So oily foods or fat containing foods on exposure to atmosphere here means oxygen. Okay, in the bracket you can write oxygen, gets oxidized. Okay, gets oxidized. But how do we know that they have undergone oxidation? By undergoing a change in what? How would we know? Smell. By undergoing a change in smell and taste. So their taste will be different, their smell will also be different. Okay, so you will know. Okay, you will know rancid food. Okay, the smell, because whenever we eat, the smell is also a major factor. Okay, and the taste, definitely your tongue will tell you the taste. So oily foods and fat containing foods on exposure, let's put S here, to atmosphere, gets oxidized by undergoing a change in smell and taste. This is known as rancidity. This is known as rancidity. So simple. Okay, I have just told you the definition of rancidity and I have also explained to you what rancidity is. Okay, rancidity is just oxidation of food. Okay, so remember this name. Now, this is good or bad? Is rancidity good or bad? Do we want our food to become rancid? No, it's not. We do not want our foods to become rancid. So it is bad. So is there a way by which we can prevent this from happening? The answer is yes, we can. Okay, so how are we preventing rancidity? So we are preventing rancidity by flushing in, okay, well, by flushing in packed foods, especially foods like potato chips. Okay, we are very fond of Lay's and Uncle Chips and all that. Okay, so whenever they are being packed, they are flushed with nitrogen inside. So the puffiness which you observe when you buy Uncle Chips packet or Lay's packet is because of nitrogen present inside the packet. Okay, and it is intentionally put there because these chips are fried in oil, and then from the factories, okay, to our home, or from the factories to our home, it takes a lot of time. Sometimes weeks and weeks and even months also. So, and then the shopkeeper has to keep it in the shop for a long period of time. So the foods, in order to prevent the chips from getting oxidized, so they are flushed with nitrogen. Okay, so flushing of chips with nitrogen is important because if we do not flush the chips with nitrogen, then the chips will undergo oxidation. Okay, which means rancidity. All right. So remember that the puffiness or the air present inside the chips packet is nitrogen. All right. So if they ask you a question, name the gas which is flushed in chips packet, flash inside chips packet, the answer is nitrogen. So this is it, class. So the lesson gets over with this. Now I will see you in the next video, and in the next video we'll start another new chapter. So thank you all for watching. Stay blessed and God bless you all.